Welcome back everyone to part 2 of our discussion on NumPy arrays. We're going to continue right where we left off last time. Okay, here we are in the notebook where we left off last time. Now previously we discussed that there's lots of different ways to create random numbers with NumPy. One way to do it is by calling np.random and if you hit tab here you'll notice that there's lots of different methods for creating random numbers, but the first one we're going to take a look at is rand, which basically gives you a random sample from a uniform distribution over 0 and 1. So what that means is if you just put in a single number here, such as 1, it gives you back one random number between 0 and 1. And it's a uniform distribution, meaning every number between 0 and 1 has the same probability of getting chosen. If you pass in 4 here, that will return back 4 random numbers. So here we can see the 4 random numbers. You can also pass in a shape. So I can say 5 by 5. Notice that this is not an extra set of tuples, it's just 5, 5, and then it returns a 5 by 5 array of random numbers between 0 and 1. So that's a uniform distribution. There's also the capability to do the same thing, but with a normal distribution. So we can say np.random.randn, and this returns a sample or samples, depending what you ask for, from the standard normal distribution. So the standard normal distribution has a mean at 0 and a standard deviation of 1. So we can ask for one number from this standard normal distribution. So you can see it's deviating off of 0 on the negative side, or we can ask for 10 random numbers, again, normally distributed around 0 with a standard deviation of 1. If you want to specify your own mean and sigma, you can say random and then call normal here. And if you do shift tab, you can select the location, that's the mean, and then the scale, the standard deviation. Okay, so lots of different ways here. There's random normal, and then another really useful one is randint. So we can say np.random.randint. And what this does, it returns random integers from a low, which is inclusive, and a high, which is exclusive. So you can decide the limits. So you can say 1 to 100, and it returns back one random number from 1 to 100. And if you keep running this, you'll get back different random numbers, or you can ask for a certain amount of numbers between 1 and 100. So then this says, give me back 10 numbers randomly chosen between 1 and 100. Okay, now as you probably notice, you're getting different random results than I am. Now what you can do is you can set a seed that sets the random state. That way the random results can actually be reproduced. So the way you do this is inside of a cell, you say np random, and then you set a seed. And the seed just has to do with the way that you initially set your random number generator. And as long as you choose the same number that I choose, we should get back the same random numbers. So what we end up doing is we arbitrarily choose any number. So I can choose 42 here, or I can choose 101, or really any number. It doesn't really matter as long as you're consistent and you're matching up with your historical generation of random numbers. So go ahead and type 42, since that's what I decided to type here in my notebook, and then say np.random.rand, and then let's go ahead and call back 4 random numbers. And as long as these two are in the same cell, and we run this, we set a seed, and if you set the same seed that I did, 42, you should get back these exact same 4 random numbers. Again, the number 42 doesn't really have any particular meaning, it's just an arbitrary number chosen, and as long as you choose the same number I do, then you should get the same random numbers. So to drive this point home, go ahead and put in 101 there, run this again, and you'll notice that you get back the same 4 random numbers. Or put in 555, run that, and again you'll notice you get back the same random numbers. Now, what you should be aware of is we get back these results consistently because the seed is in the same cell as the random number generator. If we were to ask for these numbers again and continue, you'll notice that they end up being different from that seed, that initial one. So if you ever want to make sure you get the exact same numbers I'm getting, make sure your seed and your random number are in the same cell the way I'm doing it in the videos. Okay, so that's generating random numbers and setting a seed. Let's now discuss a couple of array attributes and methods. So we're going to quickly create an array. I will say arr is equal to np. We'll use the arrange function we discussed earlier, and I'll say 25. So there's my array, and then I'm going to say random array is equal to np random.rand int from 0 to 50, give me 10 random numbers. And here we see our random array. So right now I have this arranged array and this random array. I didn't set a seed, so don't worry if your numbers are different. But what I want to show you is a couple of useful attributes and methods that we'll be using quite a bit throughout the course. The first one is reshape. So as I previously mentioned, if you have any array, you can call its shape by saying .shape. But sometimes you don't want everything as a single one-dimensional array. Instead, maybe you want a two-dimensional array. So what to do is you call reshape and then say another shape. So 5 by 5. This will return back 5 rows by 5 columns. Now something to keep in mind here is you can't just choose any arbitrary values you want. I can't just say 5, 3, otherwise I'll get an error. And that makes sense because it can't fit 25 elements into a shape of 5 by 3, since that only leaves space for 15 elements. So if you ever get this error of cannot reshape array, keep in mind and pay attention to how many elements you have versus what shape you're trying to reformat them into. Okay, so that's reshape and its relationship to shape. So again, taking this one-dimensional vector and shaping it into something else. And now let's go ahead and show you how to grab max min and then argmax and argmin. So I'm going to grab my random array. So here's some random numbers. If we ever want to figure out what the max value here is, we can say dot max, call the max, and it returns back the max value. And obviously your max value or minimum value may be different than what I'm showing here because these are random numbers. So here's the minimum value. So it looks like we got a max of 42, a min of 1. However, this doesn't actually tell me their index location. So if I actually want to figure out what location my max and min values are at, I can go like this. I can say ran r and then say argmax or argmin. And what this does, it returns back the index location of the maximum and minimum respectively. So my minimum number happened to be 1, and it's at index location 0. It's the very first number. So there it is. And 42 happens to be at index location 1. So when we say argmax, index location 1, we see the max number. Again, your values may be different since these are just random numbers. Okay, so we discussed the shape, reshaping, max min, argmax, and argmin, and how to generate random numbers. The last thing I want to show you that if you're ever interested in figuring out the type of data that's in an array, you just need to say the variable of the array and then call dtype, no parentheses, and it'll report back what type is held in the array, whether it's an integer, 32-bit, 64-bit, or float numbers, 32-bit or 64-bit. In general, we'll probably be dealing with float numbers usually throughout the course. Okay, thanks, and we'll see you at the next lecture.